Okay, ladies and germs, let's look at this review here. So they're asking the name of something, and I'm always big into processes. So my processes are: first, is it ionic or covalent? And the only way to know that is to look at it and decide if the first thing is a metal or not. So let me grab a periodic table while I'm here. All right, we know that everything that's to the right of this stair step is a nonmetal. Everything that's to the left of this stair step here is a metal. So I have silicon and I have oxygen, and those are both nonmetals, so this is covalent. So I'm going to write covalent. This is the order that I would have done this sheet in, this review in. So I'm just going to go down. Iron, definitely a metal. That's ionic. Calcium, I don't know why y'all aren't looking, but calcium is definitely a metal. That's ionic. Magnesium, definitely a metal, ionic. And then we'll deal with this stuff in a minute, right? Because from here, we're going from a name to a formula. So I'm going to continue dealing with this. Now, the rules for covalent things are if the first atom it has one atom of it, we just call it what it is. So it's silicon. And everything else has a prefix. Everything else. Only if the first atom, the silicon here, doesn't have more than one atom, then there's no prefix. Otherwise, the number of atoms tells us what the prefix is. So this is dioxide. Silicon dioxide. Why is it named this way? Because it's covalent and it has two oxygens. What is happening to the electrons? It's sharing. Sharing. Sharing is caring. Okay, now let's go to the next thing. Ionic. It's ionic. And more importantly, after we know if it's ionic or covalent, we have to know if it's a transition metal. Because in the middle of transition metals, we have to have a Roman numeral. Transition. Okay, so I've got the rules here. I have transition metals, and I'm going to write prefixes below covalent. So I know that prefixes, Roman numeral transition metals. Otherwise, it's just naming it, right? So this is iron, a number in the middle, and oxide. Now, I could show you how to get this number in the middle, but I'm going to show you down here first, and then I'm going to relate it back up to here. So let's look at this lead 4 carbonate. First of all, I know that lead is Pb, and I know that it's charged plus 4 because it says it right there, right? It says 4. That means that it's charged plus 4. And a carbonate is a CO3 group. We can find that on the back. Carbonate, CO3, it's charged minus 2. So CO3, and we know that it's charged minus 2. Put parentheses around everything. From now on, if you flip this over and it's a polyatomic, put a parentheses around it. Because I'm so tired of seeing y'all put a 2 here, CO2, or a 4 here, CO4. And then what do? These crisscross. So this charge goes down here. All ionics, when we go from a name to a formula, crisscross charges. So where do I want to write that? We'll write that up here. Name, ionic, name to formula, crisscross. Crisscross.